Hello viewers, this is the test for the detection of nitro compounds. The name of this test is ferrous hydroxide test. What you need to do over here, you have to take the given organic compound and then add freshly prepared ferrous ammonium sulfate reagent and then add 2N alcoholic KOH reagent. Stop the tube and shake it well. Note the color of the precipitate after 1 minute. The red brown to brown precipitate of ferric hydroxide is formed by the oxidation of ferrous hydroxide by the nitro compound, which in turn reduce to primary amine. If a negative test is there, it will indicated by greenish precipitate. Practically all nitro compounds give a positive test, ferrous hydroxide test, and the speed with which the nitro compound is reduced depends on its solubility. So here you can see how the color develops and you can see the reaction also. The nitro compounds get converted to amine compound and the ferrous hydroxide will get reduced to ferric hydroxide. So you can see how the reaction perform in the color of the test tube. Now after confirmation of the functional group in the given organic compound, we have to see whether the compound is solid or liquid, and we need to do the melting point or boiling point. If your given organic compound is solid, you need to perform the melting point determination, and if your given organic compound is liquid, you need to perform the boiling point. So first of all, what is melting point? It is nothing but the melting point temperature of a crystalline solid. Let me elaborate you over here. All the given organic compound which is given in the laboratory on undergraduate level are crystalline in nature. So melting point is a characteristic property and is used to identify whether the compound is pure or not. So if your given organic compound is pure, it will give you a sharp melting point. So this will tell you the identity of the given organic compound. You have done till now the preliminary test of the given organic compound. What should be the possibility of the organic compound? Thereafter you have confirmed the extra element, whether it is nitrogen, sulfur or halogens, or there is no extra element in the organic compound. Then on the basis of that point, extra element, you have already confirmed the presence of given functional group. And the next point, the next big point over here is the detection of melting point or boiling point, which will give you clear idea what should be the possibility of given organic compound. So it is very important step as far as the systematic qualitative analysis of organic compounds are concerned. What is melting point? The temperature at which the solid and liquid forms of a pure substance can exist in equilibrium, right? As heat is applied to solid, its temperature will increase until the melting point is reached. More heat then will convert the solid into liquid with no temperature change. And what is boiling point? Boiling point of a pure substance is the temperature at which the substance transitions from a liquid to the gaseous phase. At this point, the vapor phase of the liquid is equal to the applied pressure on the liquid. The boiling point we can also define in another way. At a pressure of 1 atmosphere is called the normal boiling point. The normal boiling point is high for the liquids with strong intermolecular attraction. We have discussed while discussing the organic compound chemistry, which compounds have high boiling point and which compound have less boiling point due to the presence of or due to the variations in intramolecular attraction, and low for liquids with the weak intermolecular attraction. So it will gives you that kind of idea also. Here you can see how can we proceed for the detection of melting point, right? So determination of melting point can be done in different ways. One of the way has shown in the figure in the slide. The first of all, you need to take a capillary tube. What is the diameter of capillary tube? You can see in the first figure. The person is doing the sealing of one end of the capillary tube. You may be provided with the one end of capillary tube, or sometimes if it is open by both ends, first of all you need to close the one end of capillary tube by rotating it very gently on the Bunsen burner. After this, you need to fill the given organic compound, right? How much you need to fill the given organic compound in capillary tube, that you can see from your naked eye, right? You need not to take any apparatus. So most probably it should be 1/4 or 1/3 of the length of the capillary tube. Then you have to fill the given organic compound into the capillary tube. How can you fill? First of all, make sure that the given organic compound is finely powdered. If it is not, just make it finely powdered with the help of mortar pestle. And in the figure you can see the person is taking the given organic compound in a china dish which is looking absolutely fine particles. So what he is doing? He is inserting the given organic compound by pushing the open end of capillary tube into the given organic compound. Thereafter you need to hit it on the from the closed side. After filling the given organic compound in the capillary tube, just attached it with the thermometer, right? In the third picture you can see it is not the capillary tube, it is the ignition tube, right? I will tell you in detail that is also, but you have to attach this capillary tube with the thermometer in case of you have to detect the melting point, and then bind it with any rubber, or I will say do not take rubber, I will advise you can take the copper wire which will not disturb your reaction, right? So copper wire is advisable for the safety and security reason, and at the same time it will be neutral towards your reaction. But if you want to do the boiling point, what you need to do? In the third structure you can see that this is not a capillary tube, this is a ignition tube, right, which you have used in case of detection of extra element. So if your given organic compound is liquid in nature, you have to simply fill the given organic compound which is liquid in nature in the ignition tube. Again I will advise that you need to, how much amount you need to take liquid in the ignition tube? It should be the 1/3 length of the ignition tube, and then attach it tightly with the thermometer with the help of copper wire, right? So what is the first step? First of all, you need to fill the given organic compound. If it is solid in nature, you have to fill the capillary tube. If it is liquid in nature, you can fill the ignition tube. So for melting point, you need to take the capillary tube. For boiling point, you need to take the ignition tube. For boiling point, you have to insert a capillary tube also in the ignition tube by the open end and keeping the closed end on the air, so that if the solution will boil, the bubble will rise in the capillary tube and you can easily watch the boiling point of a given organic compound. So this is how you can prepare, first of all, the first step, the setup for the melting point or the boiling point. So let me discuss first about the melting points. So in the right hand side, if you see this blue color apparatus, it is nothing but melting point apparatus, right? In the lower bottom you can see 3 knobs are there, right? So you need to first on the switch on the apparatus, and then you can adjust in the moderate temperature, and by adjusting this black knob you can adjust your temperature also. And in the figure A, here you can see this is the hole from where you can see the organic compound, and these are nothing but these are capillary tube, right? You can see your compound when have a close eye on this hole, on this black uppermost hole, and the yellow colored, you can see the yellow colored, it is nothing but a thermometer. So this is melting point apparatus. You need to insert a filled capillary tube inside the hole of the melting point apparatus. There are 3 holes, so at the same time you can determine the melting point of 3 organic compound, provided they have melting point at a wide range. Their melting point should not be very close, so you are not able to detect correctly. So how can you see from your naked eye when having close eye to this hole? You can see it will be look like as in figure A, right? Now How can you observe the melting point? When you rise the temperature will rise, and you can note down what is the temperature of the apparatus from the thermometer, right? And at the melting point of the given organic compound, the compound starts melting, and within 1 or 2 degree the whole compound will melt. So basically you need to note down the range, right? Suppose if I gave you, if in laboratory you will provided benzoic acid which is having melting point 120 degrees Celsius. So the range should be 121 to 122. You cannot observe only 1 degree, because it will rise so sharply, so immediately, that you have to take the range within 1 degree or 2 degree. And in the big figure B and C, you can see how immediately it will melt and how it look like, right? So this is how you can observe the melting point. So whether your instrument or apparatus is standardized or not, you can easily check yourself. Take some known compound which is melting point is known to you, and then you can determine the melting point by this apparatus. If it comes out correctly, then your apparatus is standardized, otherwise not. You need to standardize it. So this is how you can perform the melting point of given organic compound. The temperature at which your compound starts melting, and the temperature at which it completely melts. So basically you need to note down the range of the melting point. Here you can see some melting point of the given some organic compounds like phenol, alpha naphthol, 95 alpha naphthol is having beta naphthol 123, oxalic acid, benzoic acids. In some literature book it is 121, sometimes it is 120. Cinnamic acid, it depends on the purity of the given organic compound. So do not get confused over here. Cinnamic acid 133, paratoluidine 43, alpha naphthylavine 50. So these are basically what? Why I have shown this slide to you, right? These are the reference melting point which you may easily find in your book, in your practical book, right? So these melting point are known as reference melting point or given melting point, and there are some melting point which you have to measure yourself, right? If suppose the given organic compound is benzoic acid and its melting point which is given in the literature, that is in the book, is 121, and your melting point comes out 120 or 119 to 120. So you can see both the readings are good in agreement, and the given organic compound is benzoic acid, right? So this is how you can confirm the presence. So this is very important step to determine the melting point, which gives you clear idea what should be the possibility of given organic compound. It is nothing but on the basis of purity. You can check over here. The melting point is gave you idea the possibility of the organic compound. Here is the another method from which you can detect the melting point. However, I will advise you, if your apparatus is not standardized, then you may have this alternative method. Here you can see in the picture that you have already prepared a setup. You have already attached your filled capillary tube along with the thermometer with the help of copper wire, right? So in the picture you can see a setup is here, a U tube is here. This is nothing but a Thiel's U tube, a V shaped projected over here, and you have to fill this U tube with the any solvent. The solvent, what should be the characteristic property of a solvent, which is actually a heating medium, right? You need not to heat the given organic compound directly, you have to heat it indirectly with the help of heating medium. Here in the Thiel's U tube you have to fill either a solvent or any liquid which is having boiling point above 250 degrees Celsius. Like you can say paraffin oil, you can take mustard oil or any oil, and moreover its visibility should be clear, because you have to, after filling the given liquid in this Thiel's tube, you have to insert the thermometer which is actually attached with the capillary tube to this Thiel's tube, and then you should be able to see clearly where is the compound, whether it is liquid or solid. If you are performing melting point, you have to insert the thermometer with the capillary tube. If you want to perform the boiling point, you can insert the thermometer along with the ignition tube, because very obvious over here, you cannot fill your liquid into the capillary tube, right. So, what should be the height of this U tube? It should not very high, not very low. It should be just above to your burner, and it should be in the lower position only, because it may harm. In the lower most bottom, in the with the Bunsen burner, you can keep a plate which is filled with sand. So, if accidentally this Thiel's tube will break, the solution will absorb, the liquid will absorb by the sand, it will not harm you. So, precautions are very, very important. What you need to take? You need to take a plate, simple plate, iron plate, which is actually filled with a uniform layer of sand. And at how much you have to insert this thermometer along with the capillary tube or ignition tube to this Thiel's tube? The open end of the capillary tube or the ignition tube should not immerse into the liquid. Please be very careful, do not immerse into the liquid, right. And how much height you need to fill the liquid into Thiel's tube? Up to where your V shape is there. Do not fill beyond that limit, right. This is sufficient for you to detect the melting point or boiling point, where up to the mark of this V shape which is projected from the Thiel's tube, right. Now, this is the first step. First, make a right setup. It should not be very high or not very low, right. Then you have to keep a plate filled with sand. You have to insert this thermometer with ignition tube or capillary tube, so that the open end should be open in the air, free in the air. It should not immerse into the liquid. And now, the final step is there, that how you need to provide the heat to this Thiel's tube, by rotating the burner around the V shape. In the figure, you can say constantly burner is putting below the Thiel's tube. No, it's not like that. You have to rotate this burner around in a circular manner around this V shape. Now, what is the use of this Thiel's tube or V shape? It provides, a homogeneous heating to this your capillary tube or this ignition tube, right. So, this is how you can do this setup, and we have already told you what is melting point. The temperature at which a solid melts and becomes a liquid is the melting point. So, you have done a very important part, melting point and boiling point, which gives you clear idea. You have to observe the melting point or boiling point of the given organic compound, and then you need to compare all the above consideration like preliminary test, like extra element, functional group, melting boiling point, and all these points collectively you have to see and then compare the melting point or boiling point with the literature value. Here you should confirm, here there is no confusion anymore, you can confirm the presence of given organic compound. But what is the next step? Here again you have to confirm, there should be no minute doubt also. So, what is the next step? It is the last step of systematic qualitative analysis. This is nothing but derivative preparation. You know what are derivatives? When one moiety of a given organic compound or atom get replaced by another moiety or another atom. These are your derivative. Like we have tell you that if we talk about derivative of acid are nothing but RCOOH. If OH has been replaced by Cl, it will be your acid chloride. So, it will be your derivative, acid derivative. If we replace NH2 OH, then it will be your amide. So, this is how you can say what are derivatives. The first derivative we are discussing here about the alcohols. derivative preparation of alcohols, right? And what is this derivative? This is nothing but 3,5-dinitrobenzoate ester derivative of alcohol. To prepare 3,5-dinitrobenzoate ester derivative, the starting compound needed is 3,5-dinitrobenzoic acid, right? First of all, what you need to do, you need to prepare a chloride derivative, right? If you can recall the reactivity order of acid derivatives, you can see that you have to prepare the acid chloride, which is actually very reactive for further reaction. So what you need to do, you have to take the 3,5-dinitrobenzoic acid in a china dish, and then you have to add it 2 grams, double amount of the 3,5-dinitrobenzoic acid, phosphorus pentachloride. Do not forget that you need to add phosphorus pentachloride outside the lab, because these fumes are very hazardous to you. So please have a mask on your face and look at the flow of the air. It should be blow away from you. You should not inhale these fumes. Then what you need to do, mix the two with the help of glass rod. Mix it thoroughly, so that reaction will proceed in solid state only. Then add 2-3 ml of given alcohol, right, which you need to prepare the derivative. Stir the mixture well and then heat it on water bath gently. Then add 5 to, because you need to remove the side product. Then add 5 to 8 ml of sodium bisulfite solution and filter the product. This is how you can see how the reaction proceed. First of all, you can see 3,5-dinitrobenzoic acid, and when it react with PCl5, phosphorus pentachloride, you will get a chloride derivative along with POCl3 and HCl. That's why I said you need to heat it gently, so that the side product will removes. Thereafter you have to add the given alcohol to it, and you will get the derivative of alcohol. This is nothing but a ester derivative, which is that 3,5-dinitrobenzoate. Iodoform derivative you can also perform. You can also prepare this. How can you perform the iodoform test, the derivative? Only for few compounds. For a specific compound, what are these? Nothing but the compound which is having methyl group next to a carbonyl group. So this test is not given by every compound, but from very specific compound. Secondary alcohols with the CH3 on the carbonyl carbon carrying the OH, for example propane 2-ol, that can be oxidized to carbonyl compound of this type, also give a positive iodoform test. How can you perform? The solution in the ethanol test tube should go cloudy, and then a yellow precipitate of triiodomethane should be seen. This has a distinct antiseptic smell, and the methanol test tube should remain clear. Ethanol is the only primary alcohol which will give the reaction ethanol, the only aldehyde. How can you perform? You have to take the 1 gram of NaOH in a 10 ml of water in a conical flask, add 2 ml of alcohol, about 1 gram of iodine with constant shaking of the flask, then heat the solution in a water bath for a few minutes, cool the solution and filter the yellow solid iodoform. What should be the reaction? You can see over here, right? And I have already told you which compounds will give this particular test or this particular derivative. Only the keto compounds CH3CO or alcohols which is having CH3CHOH. Only these, yani secondary, these will give you this particular derivative, that is iodoform. How the reaction proceed? You can see over here, ethanol and methanol will not give this test, because condition is what? It should be secondary in nature. So secondary alcohol derivative can be prepared by iodoform preparation. Now derivatives of carbonyl compound. This test you have heard earlier also. But what is the beauty of this test? You can do this test for the preparation of derivative also. So what is the difference? Please listen carefully. When you are performing the test, the detection of given organic compound, the presence of carbonyl compound, you have to take the amount in a small amount, in a very small amount, a pinch of the given organic compound you have to take, and then you have to add the reagent. You can test the given organic compound, but for the derivative preparation you have to take the given organic compound in a appropriate amount. Why it is so? because you have to preserve it, you have to do the recrystallization also, and you have to do the melting point determination also. So, what is the difference? As far as the test is concerned for carbonyl compound and derivative preparation, only the variation in amount. For the test, you have to take the minimum amount, and for the preparation of derivatives, you have to take the in an appropriate amount. And what should be that? You should take at least 1 gram of the given organic compound to prepare a derivative. So, how can you perform this test? How can you prepare this derivative? The procedure will be the same, but the amount will vary, right? So, you have to take the given organic compound. Carbonyl compound can be aldehyde, can be ketone, and you have to add the reagent which should be the freshly prepared in the lab. You can prepare yourself, or you can take the help of lab staff also. So, the variation of color will depend on the kind of aldehyde or ketone. It can be yellow in color, it can be orange in color, or it can be reddish orange in color, right. So, the formation of precipitate, as we already told, they indicate the presence of carbonyl group, but you have to take the appropriate amount. You have to take the 1 gram of the aldehyde or ketone. The carbonyl compound is simply mixed with an acid solution of Brady reagent. You can see this reagent is also Brady reagent in a boiling tube. Take 1 ml if it is liquid, take 1 gram if it is solid, and then add 2-3 ml. You can add up to 5 ml also sometimes, and because ketones take some more amount, and you need to add the reagent to it, shake it well and heat it on water bath, and the precipitate form is filtered and recrystallized. And this is the reaction which I have already shared with you, but for the preparation of derivative, you can see how the carbonyl compound reacts with 2,4-dinitrophenylhydrazine and will give you a product which is actually nothing but a 2,4-dinitrophenylhydrazone, right. Examples are given with the acetaldehyde and with this cyclohexanone. So, these are some derivatives which we have discussed earlier. Hope you have understood. Thank you so much.